Yes, Meera Upasna, am I audible to you?
Yes, ma'am.
Okay.
Ma'am.
So did you give the test?
Yes,
Yes,
ma'am.
ma'am.
No. So see, let us continue further. So this will be, I think, our last 1 hour class. On Tuesday, you'll be having the exams. Then from Tuesday onwards, we'll get 2 hours. So today, magnetics will not be over. So some portion will be left. Just yes, I was saying, see, magnetics will not be completed. So some portion will be left for 40 minutes or 45 minutes that I'll complete on Sunday. Sunday we have the class, na? Sunday we'll complete. So then Sunday, rest of the portions of EMI we can start, because from Tuesday we will get 2 hours class, so we'll complete there. Now, let me start with this magnetic force on charge. So I started with it, we couldn't complete it. Force on a charge when it is present in the magnetic field, when the charge is moving, we have seen that it is Q V cross V. So direction of force, I was discussing the direction of force with you. So suppose I have the charge present here. The velocity is present. So wherever the velocity will be situated, my fingers will be pointing towards that direction. Okay. So fingers pointing to in that direction, and I'll curl it in the direction of magnetic field. Now see, these crosses show that magnetic field is inside. So this is my palm, and I will curl my fingers inside like this. So see, thumb gives the direction of magnetic field. So this is pointing towards the left, means the force is directed like this on this side. Upasna is joining her network. So, okay, let us continue further. She'll see this. Then force is QVB sine theta. And see, when we're talking about the work done and power delivered, so this is important because you have some numericals from this part. See, power is force, the dot product of force and velocity. So your when your power is 0, it means the force is perpendicular to velocity and the force is perpendicular to magnetic field. So remember, the work done and the power delivered by magnetic force is 0. So definitely you can conclude that the force is perpendicular to velocity and it is perpendicular to the magnetic field. Work done will also be 0. The power will also be 0. This conclusion is helpful. You will get numericals based on this conclusion. Then magnetic force cannot change kinetic energy. See, can you tell me which law is this? Work done is equal to change in kinetic energy.
Work energy theorem.
Yes, work energy theorem. This says that the work done is equal to the change in the kinetic energy. So if the work done is 0, if the work done is 0, work done is equal to change in kinetic energy. So the change in kinetic energy will also be 0. It means I am trying to say that there is no change in kinetic energy. Through this, change in kinetic energy is 0. I want to say that there is no change in kinetic energy. If there is no change in kinetic energy, there won't be any change in the velocity too. So have these conclusions in your mind that the magnetic force cannot change the kinetic energy. What is important for you to remember is that force is perpendicular to the magnetic field, and it is also perpendicular to velocity. Did you get this point till here?
Yes, ma'am.
Yes, ma'am.
Okay. Now let us see a question. See, this came in 2022. It says that a charged particle is moving in a uniform magnetic field. This is field. It is saying uniform magnetic field. We discussed the case of the magnetic field. So what is given? The magnetic field is given as 2i cap plus 3j cap. Then it is saying if it has an acceleration of, means acceleration is given as alpha I cap minus 4 j cap. This much meter square is given as the acceleration. This is the magnetic field, this much Tesla, and this is the acceleration. This is saying what will be the value of alpha. Now see, in this question, what is this? This is the moving particle in a uniform magnetic field. It's the particle in the uniform magnetic field. So listen here. When we're talking about the forces, when you have the forces present, what did we study? That the force is perpendicular to velocity, the force is perpendicular to the magnetic field. Because the charge is moving in the uniform magnetic field, so we can say here that force is perpendicular to velocity, force is perpendicular to the magnetic field. Both of these are valid, right? Now, we have no information about the velocity. So for us, this is fruitful. Let's ignore the velocity part. This is important. Now, what is the formula of mass? Newton's second law.
Force by acceleration.
Force is
Ma. Force is equal
M.
to Ma.
Mass into acceleration. So we can say M into A is perpendicular to magnetic field, right? So if these two quantities are perpendicular, we can say the dot product will be 0. For force and magnetic field, the dot product will be 0. Means mass into acceleration dot magnetic field. This will also be 0. Mass, when it goes on the other side, this becomes 0. Means we can take the dot product A dot B will give us 0. So we can take the dot product now. So dot product sir has already taught you. Now you are going to tell me. Meera, let's start with you. A dot B.
2 alpha minus 12.
Exactly. 2 alpha minus 12 is equal to 0. So 2 alpha will be equal to 12. Alpha's value is 6. Is the answer clear to both of you?
Yes,
Yes,
ma'am.
ma'am.
Okay. Just note down this question. See, this part, I think no need to write anything. I'll share this document the way I've shared. Did you receive current electricity's PDF?
Yes, ma'am.
Yes, ma'am.
Okay, I'll share this too later once we are completed with this chapter. Write down this question. Done?
Yes, ma'am.
Okay.
Ma'am.
Now let's come to the motion of a charge in only uniform magnetic field. So what are the things? See, velocity is constant, kinetic energy is constant. Why these are constant? The details we have already seen. Now there are 4 cases. These cases you must have already studied. So first case is when the charge is released from rest. So when the charge is released from rest means initial velocity will be 0. And see, initial velocity is 0. The charge is remaining at rest and force is also 0 here. So these are the 2 important conclusions that can be helpful for you to remember here. So what's the conclusion? That the charge remains at rest because there is no initial velocity when the charge is at rest and there is no force to move it. Then is the second case when the velocity is parallel to the magnetic field. Class, if you want me to repeat any part, just let me know. Second case is when velocity is parallel to the magnetic field. See, we have studied the formula Q V cross B. When we say Q V cross B, we want to say Q VB sine theta. Cross product also you have done. So this is QVB sine theta. So force is 0. Why we are saying force is 0? From the part that we have discussed before. Work energy theorem. Work done is 0. Power is 0. Since power is 0, that's why we are getting these conclusions. So this part we have already discussed. So force is 0. Acceleration is 0. Velocity remains constant. So the charged particle, this moves in a straight line. Like if there are magnetic fields present like this, charge is moving and the velocity is here in this case parallel to magnetic field. So it means you can say the charge is also moving inside. Magnetic field is inside, charge is also moving inside. In that case, it will continue to move straight in a straight path. Got the first two cases, right?
Yes.
Yes, ma'am.
Then comes the third case. So third case and fourth cases are different. First two cases were very easy. Now we are going to see the portion. I think Upasna, you left that time because of the network issue. Just pay attention. First part I am telling. The rest of the parts you will tell. See, there's a charged particle which is moving downwards like this. So what did I tell? We are going to use our right hand, right? We are going to apply and use our right hand for this. So velocity is downwards. So our hand will also be downwards. And magnetic field is inside. So when I'll curl the magnetic field, see, thumb is pointing towards the right. So it means the force is acting. This means that the force is acting towards the right. Okay. Let's come to this part. The velocity is towards the right. So I'll keep my palm towards the right. Okay. Now the magnetic field is inside the page. So like this, it cannot be curled. So I have to shift it. Now when I curl my fingers, thumb is pointing upwards. That is showing the direction of the force like this. Now, Upasna, you tell me the direction. If the charged particle is present here, it is moving upwards with this velocity, some velocity v. This is the charge. What will be the direction of force? Keep your right hand along the direction of velocity. Yes, Upasna?
Into
Into the page. The magnetic field is into the page.
Towards the left.
Towards the left, right. See, this is how we are putting our palm. Curling towards the magnetic field is inside. So, right. Meera, you tell me for this one, if it is moving in this direction.
Downwards.
Downwards, correct. This will be downwards because this is our palm. We'll curl it along the direction. See, magnetic field is inside, thumb is pointing downwards. Now, these were just peculiar 4 points that I had chosen. So I can see that all the forces are towards the center. It means even if I take a charge here or here, the force will point towards the center only. So ultimately, what will I get? I will get a circular motion like this. At every point, the force will be pointing towards the center. Velocity will be tangential to it. Inwards is the direction. These inwards is the direction of the magnetic field. And the charge is moving with v velocity. Direction of velocity is tangential, but we are getting a circular path. So this means that the the force which is acting, the magnetic force which is acting, is actually fulfilling the need of the centripetal force, right? There's a centripetal force which is acting. So it is fulfilled by which force? The magnetic force of the charge. Because why? How can we say? Because the characteristic of a centripetal force is that it is towards the center along the radius. So see, this is towards the center along the radius. So got this?
Yes, ma'am.
Yes, ma'am.
Now what's the formula of the centripetal force?
mv square by r.
MV
Yes.
square by.
Yes, mv square by r. So we can equate our magnetic force with mv square by r. So what all conclusions can we make? Now, these are important and you have plenty of questions from this, especially radius 1, radius, velocity. Lots of questions are there in your JEE. Different particles will be given where charges and masses will be compared. So when we are talking about the radius, it is mv by qv. From here, 1 vv will be getting cancelled. See, if you have qv B is equal to mv square by r. Your one velocity gets cancelled. From here, this is mv by qb. Now, mass into velocity is momentum. So this is what? This is momentum. Now, if you remember, kinetic energy is another formula is P square by 2m. Have you heard of this? P square by 2m.
Yes.
Yes.
So from here, we have replaced the value of momentum and we are getting under root 2m ke divided by qb. Also, through your modern physics, you must have heard kinetic energy is charged into the stopping potential. EV naught, many a times we see for the stopping potential also. So from this formula, we can replace kinetic energy further with under root 2m qb. So maximum, these are the things that can come. Any of the quantities will be constant and different charges can be given to you. One more thing, not only radius, we have the time also. Time is 2 pi m by qb. So we'll see numericals from this part. So you've understood this third case?
Yes, ma'am.
Yes.
Okay, let's come to the fourth case. Fourth case is fine. It's just that one question that I saw was from pitch. So when a charged particle is moving at an angle, at a random angle, let's say this angle is theta. So when we resolve the components of velocity, we get one component as v cos theta. Perpendicular component becomes v sin theta. Resolution of vectors also you have studied. So now what are the functions of all these vectors? See, pitch means a circular turn that is taken. Like when you rotate a screw gauge, you must have studied it in your error analysis in your class 11th. The equipments which are present, screw gauge and all, there the pitch and all these things are present. So one rotation that is present. So basically, this is the pitch. Why are we talking about the pitch? Because we have two velocities here. One is v cos theta, another one is v sin theta when we have resolved these vectors. What is v cos theta doing? V cos theta is pushing the charge forwards. It is giving the charge a forward motion. Whereas v sin theta is directed towards the y-axis. So it is giving it a circular path. So what happens? V sin theta gives it a circular path. Then v cos theta allows it to move straight. Then v sin theta gives it a circular path. V cos theta allows it to move straight. Like this becomes a path which we say helical path. This is the helical path, which is guided by v cos theta and v sin theta. Here, one thing that extra I found was pitch only. So formula of pitch is v cos theta into time. Okay. So basically you can take this as distance is equal to speed into time. So pitch is the distance. The speed that is taken is v cos theta to move it in a straight path, and t is the time. So time for the circular part, how can you write? You can write from above 2 pi m by qb. Now, all the modifications of kinetic energy and then putting this instead of this qv can also come, and all the modifications you can use depending upon the question. So this formula you can apply v cos theta into 2 pi m by qb. You remember this, that you are basically multiplying the velocity with time. What's the velocity which is moving it in a straight line? It's v cos theta. Time you already know, 2 pi m by qb. Did you get my point, class, till here?
Yes, ma'am.
Yes, ma'am.
Okay. Last part, magnetic Lorentz force. See, when electric field is also present, till now we were talking that charges were present and magnetic fields were present. But what if electric field is also present? Besides magnetic field, electric field is also present. And in this, the charged particle is moving with velocity, with some velocity. So what we say, we take into account the electric force also, and we take into account the magnetic force also, and we add it. That's it, what you need to remember. Now you know the magnetic force is Q V cross B. And what's the electric force? It's Q into E. So you take, for the magnetic Lorentz force, you take Q common. So this becomes E plus V cross B. Got it?
Yes,
Yes,
ma'am.
ma'am.
Just do one thing. Write down these two things, because right now in the numericals we'll need it. These 2 points, just write. Then I'll start with the numericals. And just say done so that I can start.
Done, ma'am.
Both of you?
Yes, ma'am.
Okay, let's start with the questions then. See, so this is from your 2019. This says that a proton and an alpha particle. Now, two particles are given. They can see, these questions are only there, formula based questions will be there. You have to just check which quantity is constant and what are the dependencies. By seeing that, you will be able to solve this question very easily. So you can just calculate the ratio, and ratio based questions are asked from this. So this is saying a proton and an alpha particle with their masses in the ratio of 1:4 and charges 1:2. In this question, it has mentioned the ratio of the charges and the ratio of the masses. This ratio should be remembered by you. In all the questions, it's not mentioned. You should know mass of the, if we consider the mass of proton as MP, mass of alpha particle is 4 times the mass of proton. This should be remembered because alpha particles, protons, electrons, these are very common particles that are mentioned in these questions. And the charge on the proton is E, electronic charge. What's the value of electronic charge, Meera?
1.6
Electrostatic
into 10
study?
to the minus 19.
Yes, 1.6 into 10 to the power minus 19. And the charge on the alpha particle becomes double of it, 2. So this should be remembered, though this is mentioned in the question. So they are accelerated from rest through a potential difference V. So see, V is included. If a uniform magnetic field B is set up, see, in the same magnetic field, the charges will be moving. So magnetic field will remain the same. Potential difference is also given us this time, that potential difference is also the same. If a uniform magnetic field B is set up perpendicular to their velocities, ratio of radii of the circular paths described by them. C class. Radius is given and you must have written right now the formula under root 2mqv divided by q into b. So straight away, let's use this formula. See what all things are constant so that you don't waste your time while writing the entire bracket again and then cancelling it. See the dependencies. 2 is a constant. You need not write. 2 will be eliminated anyways. Okay. Masses are different. So yes, it depends on the masses. Charges are different. It will depend on the charge. Potential, it's the same. The question says that the potential is the same. So potential won't change. Charge will change. Again, it's in the same magnetic field. We'll not consider the magnetic field. It's in the same magnetic field. So directly you can say m by root q, because when you rationalize the charge, if I multiply and divide it by the charge, I'll get under root. Radius is directly proportional to under root m by q. That's it. Now let's use masses ratio, 1:4. Charges ratio is 1:2. So when we are taking ratio of, we have proton first. So what's the mass of the proton? Under root, what's the mass? Take this as MP. Right now in this question it is mentioned, but you should remember it. And the charge as E divided by ratio of alpha particle. Now this time mass will be 4 MP and the charge will be 2 E. What is left ultimately from this? Root 2 by 2. Basically root 2 is left, right? 2 by 4 is there, 1 by root 2. You rationalize it is root 2, 1 by root 2. So 1 by root 2 will be A option, right? See, when you rationalize it, only 1 by root 2 will be left. From here, even without rational, see, this is 1, this is 2, that is 1 by root 2. This is 1 by root 2. So A option. Got this?
Yes.
Just write this quickly.
Done, ma'am.
Done, ma'am.
All right. So this says that two ions having same mass. Now, we don't know the names of these. It has not mentioned. So it has given us that the mass is same. Then it is saying they have the charges in the ratio 1:2. Let's say Q1 by Q2 is 1 by 2. They are projected normally in a uniform magnetic field with their speeds in the ratio. So uniform magnetic field means magnetic field will also remain constant. See, they won't give you two charges into different magnetic fields. Magnetic field will remain the same. Uniform with the speeds, yeah. So V1 by V2 is 2 by 3. Now radii is asked. So Upasna, you tell me which formula should we start with? Look into the notes.
MV by QB. R is equal to MV by Q.
Yes, MV by QB, correct. Now from this, Meera, you tell me what all things are constant?
Magnetic field is constant and mass is constant.
Yes. So basically, radius is only depending on the velocity of the charge and the velocity of this ion and the charge it is holding. So it is V by Q. So let's take the ratio then. R1 by R2 we need to find out. So R1 will be, see, first we have velocity. So it will be 2 by 3. And for the charge, it will be reciprocal because it is in the denominator. So this is 2 by 3. It will be, this is 2 by 3. And here we have 1:2, right? So it will become 2 by 1. So ratio is 4 by 3. second option. Okay, write this.
Done, ma'am.
Done.
Yes, class, tell me the answer. Now you try this. We have done 2 questions. Okay, class, I'm discussing it. Now 3 particles are given. A proton, a neutron, and an alpha particle. They are moving with the same momentum. So this time momentum is mentioned. That's constant. Magnetic field is uniform. So momentum is constant. Magnetic field, this is constant. The ratio of magnetic field acting on them and their speed is in the ratio. So forces ratio and the speeds ratio. See, first the charges, proton, neutron, and alpha particle. When you're talking about their masses ratio, so if we talk about the mass of proton, it's mp. Mass of neutron is double of it, 2 mp. This is for proton, this is for neutron, and for alpha particle, I've already told this is 4 mp. Regarding the charges, see, this is same E, this is also same E, and this is double. So again, I'm saying, see, these are the things you should remember. Like here in this question, it didn't mention. Otherwise, it sometimes in the questions, it has mentioned it. Now, P is constant, B is constant. And we need the force. So forces formula is C. Force formula is Q V into B. The formula of force is Q V B. Now, if I multiply, because momentum is given and we have no information regarding momentum. So what can we do? We have to produce it. Means if I multiply and divide it, so this m into v will become the momentum. Q, momentum into magnetic field divided by mass, right? Now from here, what are the things that are constant? Upasna, you tell.
Momentum and magnetic field is constant.
Magnetic field is constant and
Momentum.
momentum is constant. Means directly we have to see the ratio of the forces. For the forces, we have to see the ratio of the momentum by mass. Okay, we just directly have to see the ratio of momentum by mass. And see, velocity is, we have force as qvb, right? So velocity is also depending on the same thing, right? mv is basically the momentum, so velocity is also depending on the same thing. Whatever answer you will see, there can be a little difference. Let us just see first the force. So from here, the force, it will be F1 is to F2 is to F3, right? So this will be equal to charge by mass. So see, MP, E by MP. E by MP is 2. E by 2 MP is 2E by 4 MP. So you can say this is 1 by 1 is 2, 1 by 2 is 2, 2 by 4, right? So this is 1 by 2, you multiply everything with 2, you will get 4, 2, here 2, and then one more 2. 4 is to 2 is to 2. Or this can also be cancelled. Cancel it by 2, you will get 2 is to 1 is to 1. So this part, I think there isn't any other option. First one is force. This part is correct. Till here, is it right or wrong?
Yes, ma'am.
Now for the velocity, you need not do anything. See, velocity is momentum into velocity. Momentum is mass into velocity. So from here, what's velocity? It's momentum by mass. Momentum is constant. So velocity is just the ratio of masses. V1 is to V2 is to V3 when you take. Look, this will be 1 by 1. We are not considering the charges. Is 2. 1 by 2 is 2. Instead of 2, this will also be 1 this time because charges are not considered. Momentum is constant here. Only masses are taken. So this will be 4. So you multiply it with 2. You multiply it with 4 directly. So when you multiply it with 4 is 2. 2 is to 1. So B option. Am I clear?
Yes, ma'am.
Yes, ma'am.
Okay, right. I saw your homework. The first question was based on magnetic intensity. So that was just a new thing which we didn't discuss that time because it will come in the magnetism portion of your bar magnet and all. That is yet to be discussed. Rest of the things you all have given the questions correctly. Just at one point to pass now, you have, I think, missed one direction of a semicircle. Rest of the things you have mentioned. I've shared the sheets back, so you can just check. Okay,
Okay.
please write it.
Done, ma'am.
Done.
See, this question says a proton, electron, and a helium nucleus have the same energy. So this time energy is constant. They are in circular orbits in a plane due to magnetic field perpendicular to the plane. Radii are given, and then we have to compare the radius. Which formula we should use?
Root 2 mk by qb.
Yes, Upasna, which formula?
Root 2m under kinetic energy by ke.
Yes, we have to use this formula only. 2 into mass into kinetic energy. This is over root by qb. Just a minute. Okay. Yes. So under root 2 mke by qb. This formula we are going to use. Now, Meera, you tell me which all things are constant here.
Kinetic energy.
Kinetic energy is constant. And anything else?
Magnetic field.
Magnetic. Yes. Right. So see, 2 is also already just a number. So basically, radius is directly proportional to root of mass by the charge. Now, proton and electron have the same masses. Helium has double the charge. So if you put it like this, see, mass of, when you put the mass of proton, let's say this is MP, or I hope you know it is 1 AMU, which we write, atomic mass unit. Let me write MP only. 1.67, the whole value we can use later. Is to, or let's just have the radius because we don't have to find out the ratio. This is for proton. For electron, see, mass of electron, which is 9.1 into 10 to the power minus 31 kg by the electronic charge. This is also the same. And for the helium, so for the helium, see, the mass of helium is 4 times the mass of proton divided by 2e. Alpha particles that we take, same. So now we have to compare. See, if you see EE here is same, means denominator is the same. So we just have to compare the numerator. Mass of proton is greater or mass of electron?
Proton.
Proton. So see, directly here we can say mass of proton is greater than mass of electron. So radius of proton will be greater than the radius of electron. But if you compare this ratio, this is 2e. See, this is increasing with the same amount. 4 times the mass, which is becoming 2 MP only. Right? This is becoming 2 root MP divided by 2e. 2 getting cancelled. Aren't we getting the same answer? Root MP by E, root MP by E. It means radius of proton and helium are same. Is it? Right?
Yes,
Yes,
ma'am.
ma'am.
So which option? Yes, class, which option is correct?
A.
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 Yes. Write it. Now we'll discuss a little bit of the theoretical portion.
Done, ma'am.
Done, ma'am.
Okay. Now let's continue. So magnetic force on a current carrying conductor. Okay, current carrying wire. So what's the magnetic moment of a current carrying coil? By now you have discussed it in one of the classes of vectors. Magnetic moment of coil. Sir has told you also. Okay, we'll see it later. See, when we're talking about the force on a current carrying wire, so current multiplied to the cross product of the current element and the magnetic field. Basically, cross product of the length and magnetic field. So if your length is variable, you integrate it, current will be out, it's common. Many a times magnetic field will also be taken out because it will be constant, and whatever will be the coil, depending upon the total length of the coil, you can put the value. For circle, it will become 2 pi r. For semicircle, it will be pi r. Like this, you can change. One more thing, one more question I have seen. See where you have to use L equivalent. If a uniform magnetic field is mentioned, then do not use this as the entire length of conductor. When you are putting it as B cross L, current, you know, I, magnetic field, you know, it's given. But when you are using L, see, if the magnetic field is uniform and you are getting a random figure where you see the length can be given like a displacement, the way you calculate the displacement. So use L equivalent. Don't consider the entire length. Got it?
Yes.
Yes, ma'am.
Okay, and the next topic is magnetic force between two wires. So on that day, I discussed also a bit where in the question 4th you were having a doubt. So yes, recall what is the formula of magnetic force between two wires?
F is equal to mu 0 I1 I2 by pi r square.
Not pi r square. That is right.
2
Mu
pi r.
naught. Yeah. See, these are the two conductors. Both of them have the current going in the upwards direction. And the length of the conductors, this is L. Separation between them is dr. And I1 and I2, these are the lengths. Now, force between both of them, force, this is the formula of only force. Force is given by mu naught. Mu naught is 4 pi into 10 to the power minus 7, right? Mu naught is 4 pi into 10 to the power minus 7. Mu naught I1 into I2 into length. Length will be same of both the conductors divided by 2 pi r. R means the separation between them. But sometimes force per unit length will also be given. Force per unit length. In that case, this L will be divided here. So you won't be able to see this L. Mu naught I1, I2 by 2 pi r. Most of the time this is given, most of the times, because you will see in the questions length is missing. So directly apply this formula. Okay, so this is the magnetic force between two wires. One thing, see, if both the currents are traveling in the same direction, then the wires attract each other. See, if two wires are present, and in both of the wires, if both the wires have the same length, same amount of current is flowing, or the current can be unequal. Current, if the even if the current is unequal, but the length of the wires are same, the cross sectional area of the wires are same, radius also shouldn't be different, and the two wires are separated by a small separation, and within the wires, if the current is flowing in the same direction, let it be upwards or it be downwards. If it's both, in the both of the wires the direction is same, then the wires will be attracted towards each other. So wire will be attracted. And if you see two wires of the same segment having different current, same length with a small separation, but the currents are traveling in the opposite directions, one in upwards direction, other in downwards direction, you will notice the wire is getting repelled. So wire will be repelled. Now a question. So this says two long straight wires P and Q carrying equal current of 10 amperes. So now the current is also same in this question. So this is a question from 24th Jan 2023, shift 1's JEE mains paper. And these kinds of questions have come in the advanced papers too. So two wires are there, P and Q. They are having the same amount of current. They are kept parallel to each other, and the separation between the two wires is 10 centimeters. 10 amperes current, 5 centimeter separation. Now, it is saying magnitude of force experienced by 10 centimeter length of wire P is F1. So force experienced by 10 centimeter length means length is also given. This is the separation between the wires. This is the length of the wire. This is L, this is R. So L is given is F1. Now it is giving you certain conditions. So you know the formula, you know both the currents, you know you can calculate easily the force still here. But now it is saying if the distance between the wires is halved, means they are brought closer, the distance is halved between them, and the currents on them are doubled, then the force F2 on 10 centimeter length of wire P will be. Now see class, in this question, lots of data is given, 5 centimeter, 10 centimeter, 10 ampere and everything. Ultimately, it's saying that the radius is halved and the currents are doubled. So if why to put all the values, don't put the values of current and then get the value of F1 and then put this value of F1 with the data changed. You just analyze, see, for you, the entire first four lines were of no use. Just focus on the last two lines. It is saying distance is halved and current is doubled. So you have to check if distance is half and current is doubled, what all factors can occur. Clearly, I think by now you should be able to figure from the option, which option is right. See, you know what's the formula? Formula is F is equal to mu1 I1, sorry, mu naught I1 I2 divided by 2 pi R into length. This is the formula. Now, currents are also the same, right? 10 ampere current. So this will be mu naught I square L by 2 pi R. Look class, mu naught is of no use to you, 2 pi is of no use to you, length is also of no use to you, because it is saying current is doubled. So F1 is I square by R. So directly put it here. The new F, let's put it as F only. What has happened to the radius? Radius has been halved. What has happened to the current? Current has been doubled. So 2I whole square. It means I square by R into R square by, so this will become 4. 4 into 2, 8. 8 I square. I square cancel. R square will be, sorry, R will be cancelled, not square. So which option? F will be equal to 8 times F1. So see, a very big lengthy story was given, but we just required this much part. We just had to find the ratio, and in the ratio, most of the things get cancelled. So we'll just focus on things that are of use. Got this question?
Yes, ma'am.
Yes.
Okay. So just write it. And see, on Sunday we'll have 1 hour class only. So I'll conclude the entire magnetics, some portions from this, and then your chapter 5th. Okay, I'll consider that, and I'll complete it. On Tuesday, after your biology's paper, when we'll have the 2 hours class, in that I'll be taking EMI and AC together. So both, because both the chapters are very short. So 2 hours is sufficient for both of them. This is a long chapter, and we are considering magnetics chapter 5th also in it. So Sunday I'll give to magnetics only. Okay, class, is it fine?
Yes, ma'am.
So tomorrow we'll continue. Please write this and just tell me when it's done.